The topic of the report, mathematical and algorithmic support of detection useful radio signals in telecommunication networks. The authors of the research are Liliya Khvostivska, Mykola Khvostivsky, Vasyl Dunetc, and Iryna Dediv. Existing models and methods of detecting useful stochastic periodic radio signals in modern telecommunication networks implemented on their basis are characterized by a low level of authenticity of the results. When decisions are made regarding the fact of the absence or presence of radio signals in telecommunication networks, which is destroyed by various interferences. Therefore, the development of new mathematical support, in particular the mathematical model of radio signals and the implementation of new effective mathematical method and algorithm for detecting useful radio signals in telecommunication networks in the presence of interferences on its basis in an actual problem. In the development of telecommunication networks, Figure 1, the transmission-reception channel is the basic link where the source of radio signals and blocks are coordinated. Figure 2 shows an amplitude-modulated radio signal with the interferences in its structure. Amplitude-modulated radio signals in the telecommunication networks are characterized by periodicity by modulation method and stochasticity by the influence of interference of various natural and artifactual origins. These needs are agreeing a mathematical expression as a periodically correlated random process. The radio signals represent as a periodically correlated random process belong to the class Pta and represented in expression 1. The statistic of correlation components in the component processing of the radio signal are calculated according to the expression 2. Figure 3 shows a general algorithm for researching the process of detecting useful radio signals in interferences transmitted through telecommunication networks. This structure is based on precedes component processing of radio signal in the network on the background of interferences, the process of assessment component and making a decision. In the figure 4 shows algorithmic progression of detection radio signals in networks with interference. The result of calculating the correlation components of the radio signal of the network with the existing interference component with this dispersion 0 millivolts in second power, shown in figure 5. On figure 5, it can be seen that the components of the useful radio signal figure 5a are clearly localized according to the correlation components as a detection indicator, figure 5b. The result of calculating the radio signal components of the network with an existing interference component with a dispersion 1 millivolt in second power is shown in figure 6. Figure 6b shows that the components of radio signal are clearly localized, unlike radio signal implementation, where the signal is not noticeable. Figure 6a is the background of interference. Correlation components quantitatively establish the fact of the presence or absence of radio signals in the background of various types of interferences. As a creation for a more advanced and more detailed assessment of indicators of radio signal components, use the procedure for calculating the averaging by radio signal components. The average components, figure 7, provide a more detailed comparison precedes when compared with non-average components, which guarantees the effective detection of radio signals in telecommunication networks with interferences. According to the results of processing radio signals, in particular the average components of the radio signal with interference, it was established that the developed mathematical and algorithmic support provides the process of detecting and tracking the presence of useful radio signals in telecommunication networks with the given distortion. Thank you for your attention.